Hello everyone, I welcome you back to my YouTube channel. I know it's been quite a long time since I posted a new video. Yeah, the thing is I wasn't really available, so that is why. Okay, so before we get back to today's video, I just want to thank you for 100 plus subscribers. Thank you for everything you've done for me, for what you've done for my channel. I just want to ask you guys to continue subscribing, not just watch and then leave. Please subscribe for more videos. Okay, so today's question, we have this integral. Okay, we have to solve this integral, and we are going to use the integration by parts method to deal with this integral. Okay, so let's just get straight to it. Now, for the integration by parts formula, we all know we are supposed to do some kind of substitutions. All right, that is, if you have integral of u dv, it is u v minus integral of v du. Okay, so we just have to make the substitutions based on this and then that. Okay, so we just have to rewrite this integral in the form of this. Okay, so we will let our u be sq. All right, mostly the u is always like the first one over here. Then we differentiate, du will be equal to 3s squared dx. Okay, now if s cube, this s cube is u, then that means the whole of this will be our dv, right? So e power x dx will be equal to dv. Okay, now we have to find the expression for v, right? So we have e power x dx equals dv. So if you want to find v, you just have to integrate both sides to get v. Okay, now the integral of e power x with respect to x is the same thing as e power x, and then the integral of dv is just v. Okay, it's just like one is here. If you integrate one, it's the same thing as the variable, and the variable we are using is v. Okay, so we have our v to be this, right? We have our u to be also this one, and then our du to be this expression. So that is all that we need. Okay, that is all what we need. So we will have this, we've now transferred it to this. Okay, so if you want to solve it using the integration by parts formula, we just have to do the substitutions for this expression. Okay, so it will be, if you want to integrate this, it will be u v, our u was s cube, then our v is e power x, so u v will be this, then minus integral of v, our v is e power x du. Okay, integral of v du, and our du is 3x squared dx. Okay, so this is it. Now this will give us x cubed e power x minus integral of e power x 3x squared dx, right? So in order to find this integral, we have to integrate this whole thing again using the same integration by parts formula. All right, so we're just following the same procedure. So we are working for integral of e power x 3x squared dx. Let's just rewrite it in this form. Okay, so comparing this with this one, we will have our u to be 3x squared. It's just like how we did the first one, 3x squared. Then our du will be 6x dx, then dv will be equal to e power x dx, and then our v will be e power x. Okay, so it means integral of 3x squared e power x dx will be equal to u v, our u is 3x squared, in this case it's 3x squared, v is still e power x minus integral of v, which is e power x, then du, our du is this expression, that is 6x dx. Okay, so this is it. This, if you integrate this is what you get, right? So if you have to replace this with what we found over here. Then our integral of x³ e power x dx will then be, initially was x³ e power x, so it's x³ e power x minus this integral, and we found this integral to be this, right? So we are replacing it with that one. We get 3x² e power x minus integral of e power x is 6x dx. Okay, so let's remove the brackets from there. We get this minus 3x² e power x, then plus integral of 6x e power x dx. Okay, so if we are still not yet done, because we have another integral over here, so we just have to work for this integral also with the same integration by parts. So fast forward, u will be 6x, then du will be equal to 6 dx, and then e power x dx will be equal to dv, and then our v will be e power x. So it means integral of 6x e power x dx will be equal to, still with the integration by parts formula, u is 6x, v is e power x, minus integral of v, which is e power x, multiplying du, and then du is 6 dx, so we get 6 dx. Okay, so this gives us 6x e power x minus, okay, there was no x over here. Alright, so it's just du is just 6 dx, so we can bring this constant here, giving us this, right? 6x e power x, you know the integral of e power x with respect to x is the same thing as e power x, so that e power x from this integral multiplying this 6 gives us 6 e power x, right? So it means the integral of this is this, right? So we're replacing it into this expression, right? So we have x integral of x³ e power x dx. It was this expression over here, so that is x³ e power x minus 3x² e power x, then plus integral of 6x e power x, and that is what we solved over here to be this. Okay, so plus 6x e power x minus 6 e power x. Okay, so let's see if we can still simplify it further. Can we still simplify it further? Yeah, I think that will be all. Yeah, there are no like terms, so we can simplify it further. So we just write this, so our final answer. So integral of x³ e power x with respect to x becomes x³ e power x minus 3x² e power x plus 6x e power x, then minus 6 e power x, then definitely plus your constant. Okay, because it's an indefinite integral. So this will be our final answer for this integral question. Okay, so you can try it with the same question. Let's say 5x power 4 e power x dx. Okay, you can try with this, and yeah, to get familiar with the method. So thank you for watching, and I'll see you in my next video. Please do also like, subscribe, and give comments on this video. Thank you, and see you in my next video. Goodbye.